This is a continuation of the reading of Book 2 of an Aristotelian dialogue concerning the geocentric and heliocentric cosmologies, Contra Galileo, which I am the author of and which you can find a copy of in the archive and Amazon links below. Again, I wrote this as a response to Galileo's dialogue concerning the two chief world systems, as a defense of the Aristotelian and Ptolemaic geocentric model of the cosmos, and as a refutation of the heliocentric model of the cosmos, as portrayed especially by Galileo, since his work was the most important of the scientific revolution. This will be a continuation of the reading of Book 2, picking up where we left off after Simplicius had just disproved and refuted completely the heliocentric model of the cosmos, had proved it impossible for the Earth to be moving around the sun or anything else, and didn't make those arguments from probability and improbability. Not that the Earth is more probably stationary and less probably in motion around the sun, but that it is impossible for the Earth to be moving around the sun to account for the relative phenomena, or else contradictions would occur, and or else the appearances would be different from what they are, such as the rising and settings of the fixed stars without variation north or south. Again, Galileo was given a chance to collect his thoughts before he responds to the refutation and disproof, not arguments from probability and improbability, but the complete impossibility, proving the impossibility of the Earth's motion. And Galileo is here given a chance to present his view and what he takes to be the support of his view from a different angle, as a sort of intermission before he addresses the single complete refutation that the Earth cannot even possibly move around the sun to account for the relative phenomena. Because again, the sun's motion north and south, that apparent motion that is the cause of seasons, would also result if the apparent motion of the sun was attributed to the motion of the Earth, would also result in north and south variation of the fixed stars and their risings and settings over lines of latitude, which does not occur. And so the Earth cannot be in motion, or the motion of the Earth cannot account for the apparent motion of the sun, which also moves north and south through the summer and winter across the equator. And which would, if that were the case, if the motion of the sun, the apparent motion of the sun could be attributed to the motion of the Earth, would also result in an equivalent apparent motion of the fixed stars north and south, but the fixed stars, as Aristotle says, always rise and set over the same parts of the Earth and don't vary north and south. That is where we left off. And now Galileo is given a chance to present perhaps further difficulties to Simplicius and the geocentric arrangement of the cosmos, which will focus on the apparent distances of the planets, and which will lead to questions about scientific instruments. For Galileo will claim that different planets are seen to differ in distance from the Earth at different times of the year, which would attribute, if that observation, notice he's making arguments from observation, would attribute the Earth to be moving sometimes further when a planet and the Earth are on the same side of the sun. If, according to Galileo, the sun is stationary and the Earth is moving around the sun and the planets are moving around the sun, then when a certain planet is on the same side as the sun, as the Earth is on this of the sun, when the Earth and a certain planet are on the same side of the sun, the planet will appear to be closer. And when the planet is on the opposite side of the sun as the Earth, then the planet will be apparently further, which is Galileo's argument in this part. However, Simplicius will argue that those observations refer only to the position of the planets in proximity to the sun, where a sufficient observation isn't available, meaning that Galileo is talking about the observation of specific planets right after sunset, when they are drowned out in the light of the changing from day to night, and just before sunrise, where those stars appear more distant because they are partially drowned out by the light of the rising or setting sun, and they aren't seen in the pitch of night. That will be the focus of this section and will lead to questions about scientific instruments. Simplicius of Cilicia. Take your time then. In the meantime, how do you deduce that the sun and not the Earth is the center of the revolutions of the planets? You would be wise to resort to certainty and proof rather than probability and likelihood. Galileo. This is deduced from the most obvious and therefore the most powerfully convincing observations. The most palpable of these, which excludes the Earth from the center and places the sun there, is that we find all the planets closer to the Earth at one time and further from the Earth at another. The differences are so great that Venus, for example, is 6 times as distant from us at its furthest as at its closest. And Mars soars nearly 8 times as high in the one state than the other. And these are signs that they move around the sun, since their distance from the Earth would otherwise be invariant. This is reasoned out from finding that the 3 outer planets, Mars, Jupiter, and Saturn, always quite close to the Earth when they are in opposition to the sun, and very distant when they are in conjunction with the sun. This approach in recession is of such moment that Mars, when close, looks 60 times as large as when it is most distant. Next, it is certain that Venus and Mercury must revolve around the sun because of their never moving very far away from it, and because of their being seen now on one side of it and now on this side of it, as Venus's change of shape conclusively proves. Simplicius of Cilicia. Stop there, Galileo. How can you tell that any of the planets are at one time nearer? How can you tell that any of the planets are at one time nearer to us and at another time further? I know not the meaning of this, and I disagree entirely. Galileo. These things can only be comprehended through the sense of sight, which nature has not granted so perfectly to men. that they can succeed in discerning such distances and such distinctions. But in our time, it has pleased God to concede to human ingenuity an invention so wonderful as to have the power of increasing vision 4, 6, 10, 20, 30, and 40 times, and an infinite number of objects which were invisible, either because of distance or extreme minuteness, have become visible by means of the telescope. Simplicius of Cilicia. But Venus, Mars, and the other planets are not objects which are invisible because of any distance or small size. We perceive these by simple natural vision without difficulty. Why then do we not discern the differences in their sizes and shapes? Without a telescope, there is no difference or variation in the brightness whatsoever, not in the slightest bit of any of the planets in any of their positions. Only by their proximity to the glow of the sun, if near to the horizon around dawn or dusk, do the planets seem at all more dim compared to their luminescent appearance when they are well above the horizon on a moonless night. In the same way that all the stars appear less bright during the twilight hours of dawn and dusk. Is that what you mean? That their brightness is dimmed when observed in proximity to the horizon just before dawn or just after dusk? And from their relative dimness when in conjunction with the sun, you infer that they are further away from us compared to their distance from us when they are, say, 3, 4, 5, or 6 zodiacal signs away from the sun? Galileo. Yes, that is the observation I refer to. Simplicius of Cilicia. Well, I should wonder if your observations were made when any of the planets were in proximity to the full moon. If you would thereby infer from their seeming less bright at that time that they had fallen away from us however many times their usual distance for a night or two. Then once the moon passed the visual field of their proximity, that they had returned to a closer distance to us again. I should also wonder if your observation around the time of a full moon result in your inferring that each of the planets and stars are further away for being outshone in brilliance by the light of the shining moon. Galileo, are you being ironic? Simplicius of Cilicia, is not that the same phenomena as you observe when you say the planets appear more distant from us when they are in conjunction with or near to the sun, and that they appear close to us when they are in opposition to the sun? Is the case not the same when they are in conjunction with the moon, and both are in the same visible field? Galileo, I don't think they are the same phenomena, no. Simplicius of Cilicia, well, is there any other measure you use to determine the distances of these objects than their observed brightness? From what I can tell, that is your measure. Galileo, that is precisely the method by which we measure the distances of the planets. Simplicius of Cilicia, is that not in contradiction with the order of the planets themselves? Mercury, the nearest planet, is the dimmest and least bright of all, requiring a trained eye to even locate. And compared to Venus, the next planet after Mercury, his brightness is as nothing, yet Mercury is nearer, although I know you want to dispute their position, and now I understand why. I wish to avoid changing the subject for now, as that example is wrought with a further dispute. Consider Mars and Jupiter. Mars is, by both of our perspectives, closer than Jupiter. Yet Jupiter is immensely more brilliant and Mars dimmer. Again, consider Mars and Jupiter. Mars is by both of our perspectives closer than Jupiter, yet Jupiter is immensely more brilliant and Mars dimmer. You would suggest ordering the planets according to brightness, or you would have to arrange Jupiter the nearest to us after Venus, and you would have to arrange Mercury even beyond Saturn. And that is a wonder for your results, for the results of your method. How the nearest and furthest are the two least bright planets. Why then do you consider their brightness to indicate their distance? You might as well arrange them by color and place Mars first for a reason of having a hue as red as blood, and place Jupiter far away for a reason of the blue glow that surrounds him. Galileo. Once their order and arrangement are established, however, a variation in the brightness of one of them would indicate a change in distance. You must agree at least with that much. Simplicius of Cilicia. I would certainly not agree. If they were positioned at the time observed just above the eastern horizon at dawn or the western horizon at dusk, and you had not a chance to observe them during the mid of night, if they rose immediately before sunrise or set immediately after sunset, never on that night occupying the visible field during the dark hours of the night outside of your observation of them at twilight, I would then consider your observation of their change in brightness to indicate nothing about their distance, and attribute your observational results to their only occupying the visible field during the glow of twilight and setting immediately after the sun or rising immediately before the sun. Such a timed observation has great value if you are tracking the heliacal rising of a fixed star or attempting a rare glimpse of Mercury, but not in the observation of a planet's brightness to be equated as commensurate with their distance. If, however, you made your observation when the planet was at right angles with the sun, and again, when it was in opposition to the sun, and there was some significant difference in brightness, you might be worth listening to. Not when you say that the planets are closer to the Earth when they are in opposition to the sun and very distant from us when they are in conjunction with it. For I am sure that when they are at right angles with the sun, they appear equally as bright as when they are in opposition to the sun. And the only time there is any variation in their brightness is when they rise over the eastern horizon just before sunrise, and when they set over the western horizon just after sunset, when you have not the chance to make a proper observation of their brightness without the hindrance of the afterglow of twilight, or in another case, without the hindrance of moonlight, both of which resulting in a perceived decrease in brightness of any one of the planets under those conditions, under conjunction with either the sun or the moon, as compared to their opposition with the sun and the moon. Galileo. I assure you that the variation in brightness and dimness is not due to the lingering glow of the setting sun or the equivalent phenomenon of the oncoming rising sun. Again, he responds, I assure you that the variation in brightness and dimness is not due to the lingering glow of the setting sun or the equivalent phenomenon of the oncoming rising sun. You who are not acquainted with our instruments cannot contend with us about their results. For without a telescope, it cannot be comprehended that Mars does increase 60 times and Venus 40 times in one position as against the other. And their differences in distance appear to be much less without these accurate instruments. Again, you who are not acquainted with our instruments cannot contend with us about the results. For without a telescope, it cannot be comprehended that Mars does increase 60 times and Venus 40 times in one position as against the other. and their differences in distance appear to be much less without these accurate instruments. Again, he's saying that Mars appears when in conjunction with the sun, meaning when in the same zodiac sign as the sun, as very near to the sun, distant, because Mars at that point is the more dim, because the sun's glow and the inability to view Mars in the middle of the night without the afterglow of sunset or sunrise makes the planet and all the stars that are near to the horizon or anywhere in the sky appear less bright. And that Mars, when in opposition to the sun, in the opposite zodiac sign, when Mars is visible in the middle of the night without the glow of dawn and dusk, appears brighter because there's no glow of sunset or sunrise to hinder the observation at that time. And again, when the planets are in conjunction and within one sign of the sun, they are only visible for less than, say, an hour or 2 hours. Say 2 hours to view them after sunset or before sunrise, at which point your chance of observation is gone. And that period of 2 hours after sunset and before sunrise leaves the sky not completely dark, making the observation of their brightness irrelevant to their distance. Simplicius of Cilicia. I don't think that there is any difference or variance in the brightness. And I don't think that there is any difference or variance in their brightness. And I know not what you mean by difference in distance, if not by that of any of the planets, unless, as I said, they only show themselves in the night sky just over the eastern horizon at dawn, or just over the western horizon at dusk, and only briefly without giving you a chance to observe them without the glow of sunrise and sunset. And I am pleased with your admission of this one thing, that without a telescope, the peculiar phenomena about irregular distances, and I might add your unusual claim about Venus's crescent shape, to claim that she is not self-luminescent, when by unaided natural vision she is always seen to be full and resplendent, brighter than any of the fixed stars and second in brightness only to the sun, as well as the moon when the moon is illumined. That all of these claims have no basis, if not for your telescope. Again, I am pleased with your admission of this one thing, that without a telescope, the peculiar phenomena about irregular distances, and I might add your unusual claim about Venus's crescent shape, to claim that she is not self-luminescent, when by unaided natural vision she is always seen to be full and resplendent, brighter than any of the fixed stars and second in brightness only to the sun, as well as the moon perhaps, if considered when illumined. That all of these claims have no basis if not for your telescope, Galileo. And you discount our observations, Simplicius of Cilicia. Although I would like to say that you are fiddling over illusions of the lenses of your telescopic device, I need not introduce a conflict regarding the usefulness of your instruments. I only need to hold the position that brightness is neither equivalent to nor commensurate with distance regarding the planets and stars, in order to deny your claim that you observe the planets closer to the Earth at one time and further from it at another time. As I have already explained the cause of this phenomena, your observation of planets appearing less bright when in conjunction or near to the sun, and that this has nothing to do with distance, but rather with being drowned out by the afterglow of daylight when they are only visible barely above the horizon for at most a couple hours, and they're not showing themselves against the pure darkness of the night sky to provide for a comparable observation. I will now talk about the only measure of distances of the luminaries. There cannot be a more suitable way for us to order the celestial spheres than by arranging them according to the variations of their periodic times, than to arrange them according to the variations of their periodic times of completing their orbits, putting the slower further and the faster closer, putting the slower further than the faster, and putting the faster nearer to the slower. Again, there cannot be a more suitable way for us to order the celestial spheres than by arranging them according to the variations of their periodic cycles, putting the slower further than the faster, and the faster nearer than the slower. That is, unless we are fortunate enough to witness the passing of one in front of another, as we might see the moon pass in front of Mars or some other planet, indicating to us that she is nearer to us than Mars and that he is further from us than she. Again, that is, unless we are fortunate enough to witness the passing of one in front of another, as we might see the moon pass in front of Mars or some other planet, indicating to us that the moon is nearer to us than Mars by passing in front of him, and that he is further from us than she. We have made many such observations ourselves, on top of those described by the Greeks, and similar accounts of those events are given by the Egyptians and Babylonians, whose observations have been kept for very many years past. We have made many such observations ourselves, on top of those described by the Greeks, and similar accounts of those events are given by the Egyptians and Babylonians, whose observations have been kept for very many years past, and from whom much of our evidence about particular stars is derived. However, that observation is not available for all of the planets as regard to each other. We are not able to see every planet pass in front of the planet that is more distant from it. That is rather a somewhat infrequent observation that usually regards the moon passing in front of a planet, rather than, say, Mars passing in front of Jupiter. The problem of the distances of the planets is filled with difficulty because there is not another stable variable besides the rate of periodic cycles for our employment of mensuration, as their difference in brightness from one another is unrelated to their distances. Their difference in brightness is unrelated to their distances. For Mercury, the nearest of all the planets, or in your view, the second closest, appears much less bright than Jupiter, as well as than Mars, and perhaps even Saturn. Again, their difference in brightness from one another is unrelated to their distances. Their difference in brightness of the planets is unrelated to their distances. For Mercury, the nearest of all the planets, or in your view, the second closest, appears much less bright than Jupiter, as well as than Mars, and perhaps even Saturn, and undoubtedly less bright than Venus. I don't know what else you can use as a measure to find the distances of the planets. You'd better leave off aiming at a hyper-precise mensuration of their distances. The only measure of their distances is the relative timing of their completion of their periodic cycles, alongside the occasional witnessing of one of them passing in front of another, which isn't available for all of them. Beyond the somewhat obvious relations amongst them derived from those means, any specification using what I call hyper-precise estimations of their distances by decimals is futile and vain. There is not even the slightest variation of brightness of any of them that is detectable to the unaided natural eye, besides the apparent dimness caused by the dawn or dusk, which is not, there is not even the slightest variation of brightness of any one of them that is detectable to the unaided natural eye, besides the apparent dimness caused by the dawn or dusk, which is as much common to the fixed stars as to the planets, which is the cause of difficulty of observing heliacal risings. Again, there is not even the slightest variation of brightness of any one of them that is detectable to the unaided natural eye, besides the apparent dimness caused by the dawn or dusk, which is as much common to the fixed stars as to the planets, and which is the cause of difficulty of observing heliacal risings, which are important. Galileo. Then, as we cannot reach agreement about the distances of the planets, we ought to return to the challenge you posed me before, as I have somewhat gathered my thoughts about the change of polar altitude as the result of the annual motion of the Earth. And although I consider this an ongoing problem and requiring further speculation, there are a couple of ways of navigating through the challenge. Simplicius of Cilicia. I would gladly turn the conversation back to the point we left off at, for these other problems are but particulars, which would require yet others to resolve around to a conclusive demonstration of an affirmation of one or the other of our perspectives regarding the arrangement of the cosmos. How then do you propose to go about resolving the problem I set for you?